Now we look at the last example, example 3. So an open rectangular tank with a square base is to hold 16 meter cube of water. 16 meter cube of water. The material for the side and for the base costs Rm 1.2, 1 ringgit and 20 cent per square meter, and Rm 2 ringgit per square meter respectively. So for the side, the cost is 1.2 ringgit, 1 ringgit and 20 cent, whereas the base is 2 ringgit. Let X denotes the side of the base and H is the height of the tank. So A show that the cost is the given function, and finally find the value of X and H that will minimize the cost of the material. So first of all, you have to remember that. So this is quite important. This is open rectangular. So means that here is open. It's not closed but open. So here is open rectangular. So means that here is empty. So next, let's say, first we look at the area. So the area is consists of base, because the top is open top, and the side. Next thing you have to remember that the cost of the base is Rm 2 ringgit, and the cost of the side is Rm 1 ringgit and 20 cent. So this one you have to know. Next, so the area of the base is x squared. So this is the base, x times x squared, plus, whereas the area of the side, so this is the side, h times x, hx. Since we have four sides, which is left and right hand side, front and back, so we have four sides, so times 4. Now the question is, show that the cost. So now from here, I change to cost. So cost will be equals to, since the base cost is 2 ringgit, so here will become 2x squared, plus, and the cost of the side is 1 ringgit and 20 cent, so it's 1.2, 1 ringgit 20 cent, multiplied by 4hx. So from here, my cost will be equals to 2x squared plus 4.8 hx, or I can write in the form of cost is equals to, or I can write in the form of cost is equals to 2x squared plus 24 over 5 hx. From 4.8, I change to fraction, which is 24 over 5 hx. So this will be our cost. But when we compare to the given function, you can see that in the given function, here we have 2x squared. But when you look at this fraction, the h is being substituted. So next step, I will try to substitute the h. So let's say, I rewrite the cost. Cost is equals to 2x squared plus 24 over 5 hx. So now I'm going to substitute the h. So given, as the question mentioned, given the volume of the open top rectangle, open top is 60 meter cube. So based on this rectangular tank, the volume will be x times h. So means that is h x squared h. So means that is x squared h is equals to 60. So h is equals to 60 over x squared. So from here, our cost will be equals to 2x squared plus 24 over 5. H is 60 over x squared times x. So here is 2x squared plus, from here, if I try to simplify, So x can be cancelled out. Here is 1, here is 12. So from here I should have 288 over x. And this is same as the given function in A. So C is 288 over x plus 2x squared. So I try to rearrange from here. Let's say, to make sure that it's same as the given function. So it's 288 over x plus 2x squared. So next, I will try to answer question B. Find the value of x and h that will minimize the cost of the material. So next, I want to minimize the cost. So means that I have to differentiate. Before I differentiate, 288 cost is equals to 288 x power of negative 1 plus 2x squared. So first, we find the first derivative. Differentiate C, the cost with respect to x. So from here, I should have negative 288 x power of negative 2 plus 4x. Or I can write in the form of negative 288 over x squared plus 4x. Next, I let dc over dx is equals to 0. So means that negative 288 over x squared plus 4x is equals to 0, or 4x is equals to 288 over x squared. Next, multiply to the left hand side. I should have 4x cubed is equals to 288. So x cubed will be equals to 288 divided by 4 is 72. So x is equals to 4.16 meter. Next, we continue with the second derivative test. Second derivative of C with respect to x will be equals to, so from this first derivative, from here, now I perform second derivative. So this one I should have, so multiply negative 2 to the front will become 576 x power of negative 3 plus 4. Or I can write in the form of 576 over x cubed plus 4. So when x is equals to 4.16, my second derivative of C with respect to x will be equals to 576 divided by 4.16 power of 3 plus 4. So this will be equals to 12.0009. So from here you can notice that this is greater than 0. So if greater than 0, I can say that x is equals to 4.16 meter is a minimum value. So next I will try to find the value of h. Since h is equals to 60 over x squared, you can refer to this one, h. So our h is 60 over x squared. So h will be equals to 60 over x squared, where my x is 4.16 power of 2. And this is equals to 3.47 meter. So here is the value of h, and here is the value of x. So where x So here is the value of x. So where x is a minimum value.